Today we're going to start talking about sequences. This entire chapter, chapter 5, is about sequences, and then we'll talk about series near the end. So sections A and B are just an introduction to what a sequence is. So a sequence is just going to be a list of numbers that have some type of pattern. So we have different ways that we can describe, or we could write how a sequence, we could explain what a sequence is. So okay, so how can a sequence be written? The first thing we could do is we could list the terms. So for instance, if our sequence was that, we just list out the terms. Dot, 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 meaning that the pattern that we see is going to continue. So this is increasing by 1. That pattern continues for the whole sequence. In addition, we could use words. So using the same sequence that we listed the terms for, how could we describe that in words? Let's see, it starts with 2 and increases by 1. Okay, that is our description of what's happening right here. In addition, we have a formula. You'll see a lot of formulas in this unit for representing sequences. So a formula. I'm going to write the formula for this sequence. In the next section, we're going to look at how to come up with it. But right now, I'm just going to write it. So U sub n, so this is not a capital U, but a big U with a little n, equals n plus 1. So what does this mean? So U sub n, right here, this is the value of the nth term. So the nth term, the first, second, third, fourth, fifth, sixth term, whatever you want it to be. So how could we check this? So what is the U sub 1? So this is the value of the first term. The value of the first term, U sub 1. We plug in 1 for n, that's the term number, first term, plus 1, and that's 2. The first term of our sequence is 2. So if we keep checking, U sub 2 means the second term of our sequence. Plug in 2 for n. We get 3. The second term is 3. Check. And if we keep going, maybe U sub 5, that's saying the fifth term should be 6. 2, 3, 4, right? This next term right here would be 6. So that checks out. This accurately describes this pattern. Okay? But it's important to know that the U sub n is actually the value of that term. Okay? 2 is the value of the first term, 3 is our second term, 4 is our third term, 5 is our fourth term, and so on. All right, so let's start with, I'm going to give you a general form, and I want you to find some values. So example, find U sub 1 and U sub 20 for this sequence. So this wants us to find the first term and then also the 20th term. In order to find U sub 1, our first term, we take the 1 and we plug it in for n. That's going to generate our first term. So 4 times 2 to the exponent of 1 minus 1. If you want to type this straight in, just be very careful. So 4 times 2 to the... Now notice mine brings up the exponent. If your graphing calculator does not bring an exponent up like that, please let me know and I'll fix it so that it does. 1 minus 1. If yours does not bring an exponent up like that, then you need to make sure to put that exponent in parentheses. If it brings it up, it's fine. But if you have a calculator that doesn't bring it up like that, then you're going to get the wrong answer. Okay? So it should be 4 here. Or you could do this by hand. So let's see, 4 times 1 minus 1 is 0. So 4 times 2 to the 0. Anything to the 0 power is 1. So that's just 4 times 1, which is 4. To find use of 20, do the same thing, but we're going to plug in 20 for n. 4 times 2 to the 20 minus 1. So this would be 4 times 2 to the 19. 20 minus 1 is 19. 4 times 2 to the 19. Ooh, big old number there, right? 2097152. So that's how you find specific terms. Another question could ask you to generate the sequence. So they give us a sequence, u sub n equals 3n minus 1. In order to generate the sequence, we want to generate the first 5 terms or so. Okay, that's not like a set in stone number. If you find the first 4, the first 6, that's fine. But we need enough terms that we can see the pattern for the sequence. Enough terms where we go, oh, yep, that's the pattern, got it, okay? And usually 5 is a good number. So to generate the sequence, we're going to start by finding the first term, u sub 1. To do that, we just plug in 1 for n. Oops, it's a minus. 3 minus 1 is 2. Term 1. To find the second term, we plug in 2 for n. Second term. Okay? And keep going. So how about the third term? I'm plugging in for n right there in my formula. So there's my first 3 terms. If I list them out, 2, 5, 8, we might be able to pick up on the pattern from here. If not, you just find the next one by plugging in 4. What's happening is this is increasing by 3. 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 would be 11. 11 plus 3 would be 14. Okay. We generated the sequence from our general formula. So this is just an introduction, how to work with this notation, how to generate a sequence from a formula, how to evaluate a formula for certain items, for certain numbers in the sequence, and then the different ways that you could describe them. So this should get you started with sections A and B. The next video is going to work on section 5C. Thanks for watching.